Why does a light bulb turn on the moment you flip a switch? Why can a tiny 1.5-volt battery power a remote while 220 volts can power your entire home? The answer is voltage. In the next 5 minutes, you'll understand voltage so clearly that you'll never forget it. Voltage is the force, or electrical pressure, that pushes electric charges through a wire. Imagine electricity as tiny moving electrons. These electrons don't move by themselves. They need something to push them. That pushing force is called voltage. Voltage is measured in volts, represented by the letter V. The unit is named after the famous scientist Alessandro Volta, who invented one of the first electric batteries. The easiest way to understand voltage is by comparing it to water flowing through a pipe. Imagine a water tank connected to a pipe. The water pressure pushes water through the pipe. If the pressure is low, only a little water flows. If the pressure is high, more water flows. Electricity behaves in a similar way. Voltage is like water pressure. Current is like the flow of water, and the wire is like the pipe. This is why voltage is often called electrical pressure. Let's look at some examples you see every day. A small AA battery produces about 1.5 volts. A smartphone battery operates around 3.7 to 4.2 volts. A car battery provides 12 volts. In many countries, household electricity supplies around 220 to 240 volts. Different devices require different voltages to operate safely. Imagine a world without voltage. Every home would become completely dark because there would be no electrical energy to power anything. Without voltage, the ceiling fan cannot rotate because the electric motor receives no electrical pressure. The television also remains off because there is no voltage to power its electronic circuits. The refrigerator stops working, which means it can no longer keep food fresh or maintain a cold temperature. The laptop cannot turn on because there is no voltage available to supply electricity. Many beginners confuse voltage with current, but they are different. Voltage is the pushing force. Current is the actual movement of electric charge. Think about a river. The pressure pushing the water is like voltage, while the amount of water flowing is like current. Remember this simple sentence: voltage pushes, current flows. Why do engineers need voltage? Electrical engineers use voltage every day when designing. Power homes safely. Run factories efficiently. Generate electricity. Charge electric vehicles. Build renewable energy systems. Understanding voltage is the first step toward learning electrical engineering. Thank you for watching. I hope this video helped you understand what voltage is in a simple way. If you enjoyed this lesson, please like this video, subscribe to Engineerverse, and press the bell icon so you never miss our upcoming electrical engineering tutorials. In the next video, we'll explore what electric current is and how it works with voltage.